So section 3.3 are truth tables for the conditional and biconditional. Okay. So we're going to start with the conditional statement because the biconditional kind of takes two conditional statements into consideration. And so what we're really going to do is think of an if-then statement. And I'm going to say one that hopefully resonates with you. If you get an A, then I buy you a car. Okay. So this is a conditional statement. I'm starting with the phrase P, you get an A. If that happens, then I'm going to follow through and I'm going to buy you a car. Okay. So basically, I want to see what happens. If you get an A, that could be true or false. You don't know. You're still in the class. So this could be true, could be false. I buy you a car could also be true or false. We want to see when is this conditional statement true. Basically, I don't want to break my promise. If you get an A, I better buy you a car. If you don't get an A, what happens really doesn't matter because you didn't uphold your end of the bargain. But if you get an A and I don't buy you a car, I've gone back off my word. So the statement is going to be true except when I break my promise. Okay. So we're going to create our truth table and I'm going to dissect it just in terms of this phrase. We've got values for P and Q, and then we've got our conditional statement. Okay. So they could both be true, which means you get an A and I bought you a car. One could be true, one could be false. Then we can have the reverse. So one could be false, one could be true, and they could both be false. Okay. All right. So I'm going to call this case 1, case 2, case 3, and case 4. And we're going to dissect each of them. Okay. So for case 1, okay, they're both true statements. So both you get an A and I buy you a car are true. Okay. So pretty much you got an A, so I bought you a car. They're both true statements. So here I kept my promise. So the statement P, if P then Q, is true. You did get an A and I bought you a car. You upheld the condition. I followed through on my actions. So this conditional statement is true. Okay. If we move on to the second case, that says you got an A, but P is false. Or Q is false. So I didn't buy you a car. So you got an A. So you upheld your end of the bargain, but I didn't buy you a car. Okay. And that's a problem. I didn't keep my end of the deal. So here I broke my promise. So my conditional statement, if P happens, then Q happens, is false. Okay. And that makes sense. If P happens, which it did, Q should happen, but it didn't. So I didn't perform something accurately. For case 3, this is where it gets a little funky. Okay. Case 3, you did not get an A. So you did not uphold what you needed to. But the end statement is true. I still bought you a car. Okay. So ultimately, I actually didn't break my promise. You did not get an A. So I was not required to do anything at all. If I did it, great, that works out for you. But if I didn't, it doesn't matter either because you didn't do what needed to be done. So ultimately here, I didn't break my promise. Because you didn't uphold your condition. Okay. So what I do doesn't matter. Okay. So ultimately, this is a true statement. Okay. In this final case, you did not get an A, but I also did not buy you a car. So same thing happens. You didn't do what needed to be done. So I did not break my promise. This is a true statement. Okay. I still did not break my promise. All right. So if we go back to our chart now, the only time we have an issue is you start out true and imply something is false. So that is the only time we have a problem for these conditional statements. Okay. If I start out false, what happens does not matter because you didn't uphold your end of the bargain. So if you're ever unsure, think of this phrase and you're going to figure out, okay, I didn't do this, so what happens doesn't matter. Oh, I did get an A, but you didn't buy me a car. Okay, and then I'm in a hot spot. This isn't something that's true. So that's just kind of a note here. The conditional statement if P then Q is only false in the case where you start out true and imply something is false in the end. Everything else is good. Okay. So let's try some examples. We're going to do one, and then I'm going to go ahead and do our biconditional after that. So we're going to construct a truth table for not P, then Q. Okay. So still at the start, I have P, I have Q. I've got 4 possibilities for their combinations. Before I can do this main thing in the middle, I've got to find not P. Okay. And then once I have not P, I can do if not P, then Q. All right. That is everything we need for our truth table. And it's going to have 4 rows because it's 2 statements. And so that is all of our columns we need. I'm also going to show you, because I know your homework looks a little bit different. In terms of the exam, you're going to pick the appropriate truth table that fills in everything correctly. You still run through the same starting list: true, 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 false, false, true, false, false. To do not P, we go ahead and take all of these values and switch them. So it becomes false, false, true, true. Okay. What you're going to see in your homework is when you kind of have a bunch of combinations like this, it might not even have this section here. That might be gone. What it'll do is it puts like text in boxes that you have to fill in. Try my best to replicate what you'll see on your homework. Let's make this one a little bit bigger. Okay, and then you're going to see something in the middle as well. I know it's not the most fun, which is why I want to go over it. Okay, so this would be pretty much gone. What you would do in these boxes is fill in the values of not P. In these boxes, fill in not Q. And in these boxes, you put that conditional statement. So I'm also going to do it without these boxes too. Okay. But not P would be the statements false, false, true, true. You input Q's values here. And then in the middle is this conditional. So basically, you're starting false, going to true. That tells me my conditional is a true statement. Starting false and going to false, my conditional is true. Starting true, going to true, my conditional is true. And here's our bad case. I'm starting true and going to false. So my conditional is false. And I put an F here, but said true. Okay. This is the only bad case here when I start true and go to false. Okay. So I'll try to fill in here. These are the values of not P. Trying to make something a little lighter. These are the values of Q. And these are the values of that conditional statement. So this is what your homework will look like. Okay. Now, I personally am not a fan of this, but I don't have a control over how those are input. I like my normal truth table much better. So I'm going to go ahead and duplicate it and erase a ton of stuff. Okay. Let's see if I can move stuff easily. I'll worry about that later. Okay. All right, so what I like to do instead is I'll put my truth values of not P. So false, false, true, true. We're doing the conditional. And then I'm going to put my values of Q. So true, false, true, false. Okay. And now it's a little more clear to see I start out false, so you didn't get an A. Does not matter what happens at the end. In these two cases is when I have to be a little more concerned. You got an A in both of them, so I better have bought you a car. In this case, I did buy you a car, but in this case, I did not. So my end statement is false. Okay. Okay. So the last thing we're going to do is go through our biconditional statement. We'll look at that truth table. And then we'll just do a couple more examples, and that's going to give us rise to some new definitions that we have. Okay. So remember or recall the biconditional which is P if and only if Q, really means two things. It means you have the forward arrow and you can really have the backward arrow. Okay, so the arrow can go either way. And ultimately, this one's going to be put as Q starts, P follows, because we don't like using that backward. Okay, so these are what the biconditional means. Both the forward arrow and the backward arrow has to hold. So I'm going to go ahead and I'm going to look at a truth table for this. We're going to start with P and Q. We're going to look at that forward arrow. We're going to look at the backward arrow. So that means starting with Q and going to P. And then we're going to do the double-sided arrow, which basically means I have the forward arrow and I have the backward arrow. So creating a kind of long table, but it's going to be condensed in just a minute. And it looks a lot longer than it actually is. Okay. So we've got our same truth values, both true, one false, false, true, false, false. Okay. Our forward arrow, we start with P. Oh, well, that's interesting. Okay. Start with P. We're doing our forward arrow and ending with Q. Okay. And so I start out true and go to true. This is a true statement. This is our problematic statement. And when I start out false, what happens in the end doesn't matter. So these are both true. Now, if I do the backward arrow, I start with P or Q. So that's true, false, true, false. And we're going to P. So basically, I'm just flipping these arrows in the middle. And P is true, true, false, false. So I start out true. I don't end false, so that's good. When I start false, what happens doesn't matter. Here is my bad case where I start false and go to true. And when I start false, again, it doesn't matter. So now we're asking for the biconditional, are both arrows true? And that gives us the truth value of our biconditional. Okay. So I've got my forward arrow and my backward arrow. I need both of them to be true for the biconditional to be true. So here they're both true, not both true, and true. Okay. So this leads to a much more condensed truth table. But this last one gives you the reasoning why. I've got P, I've got Q, and I've got my biconditional. And I've got my 4 possibilities. So they both can be true, one true, one false, false, true, false, false. Okay. So we figured out if they're both true, the biconditional is true. If one's true and one's false, the biconditional is false. And if they're both false, my biconditional is true. So pretty much you have to be able to put the arrow forward and you have to be able to put the arrow backwards. So when they're differing truth values, like here, I can put the arrow this way. I can't put it that way, which is why I get something that's false. Same thing here. When I put it this way, I'm false, even though when I put it that way, I'm true. Okay. So ultimately, when they match in truth value, so it's double by, I get a true statement. So if they match in the beginning, or matching truth values leads to a true biconditional. It doesn't matter whether they're both true or both false, as long as they match. When they're different, so these are different truth values, these are different truth values, we get a false statement. So when they differ, the biconditional is false. Okay. So I'm going to do 3 more truth tables to kind of take everything into consideration with biconditionals, with our forward arrows, just our regular conditionals. We're going to go through a few more examples. Okay. And each one of these you're going to see is going to have a special ending truth column that tells you a special definition as well. Okay. So we're going to construct a truth table for the following statements. And the first one we're going to do is not P and Q if and only if not Q. Okay. And the one thing I want to point out is you've got this biconditional inside the parentheses. This not isn't like a super strong, what do I want to say? Super strong like operator. This is going to be your main thing because I'm going to find this first, I'm going to find this, then I'm going to take this end that's in the middle. So when that happens, when you have and or, that leads to a compound statement instead of that conditional. If the main operation is the arrow, then it's conditional. So here, and is the main operation. And likewise, or if you have or. Kind of silly to write or. But if this was an and or an or, it's still considered a compound statement. When it's an arrow, that's going to be when you have a conditional statement. Okay. So we've got our 2 statements, P and Q. I've got to find a bunch of stuff before I can do that main operation. So I've got to find not P, so I might as well find that first. Before I can do this arrow, I've got to find not Q. So let's go ahead and find not Q. Then once I have not Q, I can find the stuff in the parentheses. So that's going to be Q if and only if not Q. And then I'll have this piece and this piece. I can go ahead and do my end. So it's not P and Q if and only if not Q. Okay. And I've got just 2 statements. So 4 rows in my truth table. Okay. So let's start by filling in our starting truth values. Then we go to not P. So this is going to flip all of P's values. Not Q does the same. Let's go ahead and label these. I flip those values. I go ahead, flip Q's values. Okay. Now I'm looking at Q, if and only if not Q. So I'm going to put Q's values first, which is true. Just erase that. True. Oh, my iPad's got a mind of its own. There we go. Let's see if this fixes it. Okay. Q is true, false, true, false. We're doing our biconditional. And then not Q is false, true, false, true. Okay. So these never match. So this biconditional is always going to be false. Okay. Now I'm asking and, is not P and not Q true? So not P is false, false, true, true. We're doing the AND operation. But this is always false. So my end statement is always false. Okay. So when you have a compound statement, so the main operation is AND or, and you end up with a statement that's always false, that's going to be a self-contradiction. So a self-contradiction is a compound statement that is always false. Okay. So I got two more, and then we will be done with this section. We're going to do not Q, then P, or not Q. And so again, the main operation we have here is this or, because I've got to find this first, and then afterwards I find the or. So this is also considered a compound statement. Okay. So I need to find P and Q. I got my two statements to start. I've got to find the stuff in here, but that requires me to have not Q, which is good because that's what I need at the end. But once I have not Q, then I can find not Q, then P. Okay. Then I'll have this statement, I'll have this statement. I can go ahead and do my main or operation. So not Q, then P, or not Q. Okay. So again, we've got 4 rows. Okay. So P and Q are true, 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 false, false, true, false, false. Not Q switches all of our values. So this is false, true, false, true. And then I want to start with not Q. So I'm going to put those truth values. We're doing our conditional. And then I want to put P's truth values. Okay. And the only case I have that's bad is here when I start true, but I don't follow through on my promise. So this one is false. All of these others are good though. Okay. Now I can do my or, put my truth values of this first statement. That's true, 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 false. We're doing or, put not Q, which is false, true, false, true. And we're just asking, is one or the other true? And in all of these cases, yes. Okay. So I've got a compound statement now that is always true. This is called a tautology. So a tautology is a compound statement that is always true. Okay. One final one. We're going to do P, if P, then P or Q. So you can see I can find this stuff first. My main operation is going to be this arrow. So that is our conditional statement. Okay, that is the main operation that we have to do. So I need my statements P and Q. Before I can do the conditional, I've got to do P or Q. And then we can do our final conditional statement. So they are both true, true, false, false, true, false, false. We are doing or to start. So I want to put P's values, my or symbol, and then Q's values. And as long as one is true, my or is true. So these are all true, but here they're both false, so one or the other is not true. And then I'm starting with P. I'm going to this statement P or Q. So we'll start by putting P's truth values. We're doing our conditional, and then we'll put the values of P or Q. Okay. And again, my only problematic case is when I start true, but I don't lead to something that's false. So these are both true statements based on those starting truth values. When I start false in my conditional, what comes next does not matter at all. Okay. So no matter the truth value I start with for P or Q, I give you a statement in the end that is always true. And because the main operation is that condition, it's not called a tautology, it's called an implication. This is always implied. It's something that's accurate. So an implication is a conditional statement that is always true. So in your homework, you're going to be asked, is this a tautology, implication, self-contradiction, or nothing? If it's nothing, it's going to be the case when you have a mixture of true or false in the end. But that is it for this section. What we're going to talk about in the next couple sections are arguments. So we're going to see how to form an argument based on these values. We're also going to talk about when statements are equivalent to each other. And that basically means they're going to have the same truth values in the end. And then we will go through another type of argument, which is called syllogisms. So that one's usually pretty fun. I think you'll like it.